You know what's funny? Right now, as you're lying there trying to fall asleep, you're actually hurtling through space at about 515,000 miles per hour, and you can't even feel it. Not even a little bit. Tonight, we're going to explore 100 facts about our home galaxy, the Milky Way. But don't worry, we're not going anywhere fast. In fact, we're going to slow way down and let these cosmic wonders carry you gently into the most peaceful sleep. So settle in, get comfortable, because the universe has some beautiful secrets to share with you tonight. Our galactic home. Let's start with something simple, something grounding. The Milky Way is a barred spiral galaxy. Picture it like a cosmic pinwheel, with arms that swirl outward from a bright, elongated center. It's beautiful, really. When you see those images from space telescopes, it looks like a hurricane made of light. And it's ancient. So ancient, the Milky Way began forming about 13.6 billion years ago, just a few 100 million years after the Big Bang itself. Think about that for a moment. Our galaxy is nearly as old as the universe. It's been here, spinning slowly, long before Earth existed, long before anything you've ever known existed. It's about 100,000 light years across. Now, a light year is the distance light travels in 1 year, and light moves at 186,000 miles per second. So we're talking about distances so vast, they make the mind go quiet just trying to imagine them. And that's okay. Let your mind rest in that vastness. The Milky Way contains between 100 billion and 400 billion stars. The number is hard to pin down exactly, which is kind of charming, isn't it? Even with all our technology, the universe keeps some mysteries. Each of those stars might have planets. Some of those planets might have life. But tonight, we're just here, you and me, floating through this cosmic garden together, structure and shape. Our galaxy isn't flat like a DVD, though that's how we often picture it. It's more like two fried eggs placed back to back. There's a thin disk where most of the stars live, and then a thicker bulge in the middle. And if you could see it from the side, you'd notice it's slightly warped, like someone bent it gently while it wasn't looking. The central bulge is about 10,000 light years in diameter. That's where the oldest stars live. Ancient, red, and tired. They've been burning for billions of years, and they glow with a warm sunset light. Wrapped around all of this is something called the galactic halo. It's roughly spherical, and it extends maybe 130,000 light years from the center. This halo is home to globular clusters. These dense, ancient balls of stars that orbit the galaxy like distant moons. There are about 150 of them that we know of, each one containing hundreds of thousands of stars packed so tightly together that if you lived on a planet in one, your night sky would be spectacular beyond words. The disk itself where we live is divided into several spiral arms. There's the Perseus arm, the Norma arm, the Scutum Centaurus arm, and the Sagittarius arm. They're named after the constellations they appear in from our viewpoint. We live in a smaller, partial arm called the Oryx Spur, or sometimes the local spur. It's like living on a side street off the main cosmic highway. These spiral arms aren't solid, by the way. They're density waves, regions where stars and gas bunch up temporarily as they orbit, like cars slowing down near highway construction. The arms move, but the stars flow through them, like water flowing around stones in a stream. Our place in the galaxy. Earth sits about 26,000 light-years from the galactic center. We're out in the suburbs, you might say, far enough from the chaos of the center to enjoy some peace and quiet, close enough to still be part of the neighborhood. And we're moving. Always moving. Our solar system orbits the center of the Milky Way at about 515,000 miles per hour. At that speed, it still takes us about 225 to 250 million years to complete one orbit. Scientists call this a cosmic year, or a galactic year. The last time Earth was in this exact spot in its orbit, dinosaurs were just beginning to emerge. By the next time we complete an orbit, who knows what or who will be here? From our perspective here on Earth, we see the Milky Way as a glowing band across the night sky. That's because we're looking through the disk, edge on. All those billions of stars blend together into a river of light. Ancient Greeks thought it was milk from the goddess Hera. Norse mythology called it the path souls took to reach the afterlife. In China, it was a silvery river separating two lovers, crossed only once a year by a bridge of birds. Every culture that looked up had a story for it. We can't see the center of the galaxy with visible light, though. There's too much dust and gas in the way. But with infrared telescopes and radio waves, we can peer through the fog, and what we find there is both beautiful and terrifying. The heart of the galaxy. At the very center of the Milky Way lies something called Sagittarius A star. It's a supermassive black hole, and it weighs about 4 million times as much as our Sunday. 4 million suns, crushed down into a point so small, so dense, that not even light can escape once it gets too close. Now, before you tense up, breathe. That black hole is 26,000 light-years away. It's not coming for us. It just sits there, quiet and patient, holding the galaxy together with its gravity. We didn't even know it was there until relatively recently. In 2002, scientists watched a star called S2 complete an orbit around something invisible at the galactic center, moving at 3% the speed of light. That's when we knew for sure there was something massive and dark at the heart of the Milky Way. In 2022, we got our first actual image of it. Well, not the black hole itself, you can't photograph darkness, but the glowing ring of superheated gas swirling around it. It looked like a blurry orange donut. And honestly, for something so cosmically powerful, it looked kind of friendly. Black holes get a bad reputation, but most of the time, they're just there, quiet. Sagittarius A star is actually pretty calm as supermassive black holes go. It occasionally snacks on a passing gas cloud or a wandering star, letting out a brief flare of radiation. But mostly it just exists, anchoring our galaxy with its immense gravity. Stars upon stars. Let's talk about the stars. Those 100 to 400 billion lights scattered through the galaxy like grains of sand on an endless beach. Most of them are red dwarfs, small, cool stars that burn their fuel so slowly they could shine for trillions of years. They're the quiet, dependable neighbors of the galaxy. Not flashy, but reliable. About 70% of all stars in the Milky Way are red dwarfs. Then there are stars like our Sun, medium-sized, yellow, comfortably middle-aged, at about 4.6 billion years old. Our Sun is actually in the top 10% of stars by mass, which sounds impressive until you meet the real giants. Blue supergiants and hypergiants are the celebrities of the galaxy. Massive, bright, and burning hot. Stars like Rigel or Deneb shine with the light of tens of thousands of suns, but they pay a price for all that brightness they burn through their fuel in just a few million years. They live fast and die young, often exploding as supernovae. Speaking of supernovae, the Milky Way hosts 1 or 2 supernova explosions per century. These stellar deaths are so violent that, for a brief moment, a single star can outshine the entire galaxy. The shockwave spreads outward at millions of miles per hour, and in its wake, heavy elements are scattered: carbon, oxygen, iron, gold. The very atoms that make up your body right now were forged in ancient stars that exploded long before our sun even existed. You are, quite literally, made of stardust. There are also binary stars, 2 stars orbiting each other. About half of all star systems in the galaxy are binaries or multiples. Imagine a planet with 2 sunrises, 2 sunsets. Imagine the way shadows would dance. Nebulae. Between the stars lie clouds of gas and dust called nebulae. Some are dark, blocking the light behind them. Others glow with incredible colors: reds, blues, greens, lit up by nearby stars. These nebulae are where stars are born. Gravity slowly pulls the gas together, and over millions of years, the cloud collapses, heats up, and ignites. A star is born, and around it, from the leftover material, planets might form. This is how our solar system began 4.6 billion years ago, from a cloud that once drifted through the Milky Way. The Orion Nebula is one of the most famous, a stellar nursery just 1,350 light-years away, visible even to the naked eye as a fuzzy patch in Orion's sword. Inside it, hundreds of baby stars are flickering to life right now, even as you rest here. Another famous one is the Eagle Nebula, home to the pillars of creation, those towering columns of gas and dust that the Hubble telescope photographed. They're about 5 light-years tall, and they're actively forming new stars. Though, fun fact, those pillars were probably destroyed by a supernova shockwave about 6,000 years ago. But since they're 7,000 light-years away, the light showing their destruction won't reach us for another 1,000 years. So in our sky, they still stand, majestic and eternal. Planets beyond count. The Milky Way isn't just stars. It's teeming with planets, billions of them, maybe even trillions. We've confirmed the existence of more than 5,000 exoplanets so far, planets orbiting other stars, and we've only searched a tiny fraction of the galaxy. Statistical estimates suggest there might be at least 1 planet per star. That means hundreds of billions of worlds out there, some rocky like Earth, some gas giants like Jupiter, some strange and exotic beyond anything we've imagined. Some of these planets orbit in the habitable zone, that Goldilocks region where temperatures are just right for liquid water. And where there's water, there might be life. We don't know yet, but the possibility hangs there in the darkness, tantalizing and beautiful. There are planets where it rains glass sideways, driven by winds faster than sound. There are planets orbiting 2 suns. There are rogue planets, ejected from their solar systems, wandering the galaxy in darkness. Each one is a world, with its own weather, its own geology, its own story. Dark matter and dark energy. Now, here's something wonderfully strange. Everything we can see, every star, every planet, every nebula, makes up only about 15% of the Milky Way's mass. The rest? It's something called dark matter. We can't see it, we can't touch it, it doesn't interact with light at all, but we know it's there because of the way galaxies move and the way gravity behaves. Without dark matter, galaxies would fly apart. It's like invisible scaffolding, holding everything together. What is it? We don't know. It's one of the biggest mysteries in science. And honestly, there's something peaceful about that. Even with all our knowledge, the universe still has secrets. The darkness still holds wonder. Dark energy is even stranger. It's a force that's causing the universe to expand faster and faster. But that's a story for another night. For now, just know that the Milky Way floats in an ocean of mystery. And that mystery is part of what makes it beautiful. The local group. The Milky Way isn't alone out here. It's part of a collection of galaxies called the local group. There are about 80 galaxies in this cosmic neighborhood, bound together by gravity. Our closest major neighbor is the Andromeda Galaxy, about 2.5 million light-years away. It's slightly larger than the Milky Way, containing about 1 trillion stars. On a dark, clear night, you can see it with the naked eye, a faint smudge of light in the constellation Andromeda. And here's something fascinating. Andromeda and the Milky Way are moving toward each other. In about 4.5 billion years, they're going to collide. Now, don't worry, you won't be around for it, and neither will anyone you know. But when it happens, it will be spectacular. The two galaxies will merge, their stars interweaving like dancers, and eventually they'll form one giant elliptical galaxy. Some scientists have already nicknamed it Milky. Despite this collision, almost no stars will actually hit each other. Space is so vast, so empty, that two galaxies can pass through each other and their stars will mostly just miss. It's like two swarms of fireflies flying through each other on a summer night. The galactic disk and star types. Within the Milky Way's disk, stars are organized into what we call populations. Population 1 stars are young, metal-rich, and live in the spiral arms. Our Sun is one of these. Population 2 stars are older, metal-poor, and found mostly in the halo and the bulge. They're the galaxy's elders, born when the universe was younger and simpler. The disk is only about 1,000 light-years thin, compared to its 100,000 light-year width. If you shrunk the Milky Way down to the size of a dinner plate, the disk would be thinner than a sheet of paper. Within this disk, the density of stars varies. Near the center, stars are packed more tightly on average. There's a star every few light years. Out where we are, in the galactic suburbs, the nearest star to our Sun is Proxima Centauri, about 4.24 light-years away. That's relatively close, galactically speaking, but it's still an incomprehensible distance, about 25 trillion miles. The rotation curve problem. Here's something that puzzled scientists for decades. When they measured how fast stars orbit the galactic center, they found something odd. Stars far from the center were moving faster than they should be based on the visible mass of the galaxy. According to physics, Objects farther from the center of rotation should move slower. Like planets in our solar system, Neptune orbits much slower than Mercury. But in galaxies, the outer stars move just as fast as the inner ones. It's like a record spinning at the same speed at its edge as at its center. This discovery led to the theory of dark matter. There must be additional mass we can't see, spread throughout the galaxy in a halo, providing extra gravity to keep those outer stars moving so fast. It's invisible, mysterious, and absolutely essential. Without it, the Milky Way as we know it couldn't exist. Cosmic recycling. The Milky Way is constantly recycling itself. Stars are born from clouds of gas and dust. They live for millions or billions of years, and then they die, returning their material to space. Small stars like red dwarfs just gradually fade away, cooling over trillions of years. Medium stars like our Sun will swell into red giants, then puff off their outer layers, creating beautiful planetary nebulae, leaving behind a white dwarf, a dense, hot ember slowly cooling for eternity. Massive stars go out with a bang. They explode as supernovae, releasing more energy in a few seconds than our Sun will produce in its entire lifetime. These explosions forge the heaviest elements, gold, platinum, uranium, and scatter them across space, where they'll eventually become part of new stars, new planets, maybe even new life. Every atom of iron in your blood was created in the heart of a dying star. Every breath you take contains atoms that were once part of other stars, other worlds. We are connected to the cosmos in the most intimate way imaginable. The galactic habitable zone. Not all parts of the galaxy are equally friendly to life. Too close to the center, and there's too much radiation from the black hole and from frequent supernova explosions. Too far out, and there aren't enough heavy elements to form rocky planets. We live in what's called the galactic habitable zone, a ring-shaped region where conditions are just right. Enough heavy elements to build planets and life. Enough distance from cosmic violence to let that life evolve in peace. Enough time for intelligence to emerge. It's another Goldilocks situation. Not too hot, not too cold, not too safe, not too dangerous. Just right. And here we are, in our perfect little spot, wondering if we're alone. Star clusters, families of stars. Throughout the Milky Way, you'll find star clusters, groups of stars born together from the same cloud of gas, now traveling through space as a family. Open clusters are loose associations of a few hundred to a few thousand stars. The Pleiades, the Seven Sisters, is a famous example. These stars are young, hot, and blue, still close to where they were born. Over time, gravitational interactions will scatter them, and they'll drift apart, each star going its own way. Globular clusters are different. These are ancient, densely packed spheres of hundreds of thousands or even millions of stars. They orbit the galaxy in the halo, and some of them are nearly as old as the universe itself, 12 or 13 billion years. If you lived on a planet in the core of a globular cluster, your night sky would never be dark. Thousands of stars would be close enough to cast shadows, to read by. It would be a sky of perpetual twilight, filled with the gentle light of ancient suns. The Milky Way's magnetic field. The galaxy has a magnetic field threading through the dust and gas like invisible silk. It's incredibly weak compared to a refrigerator magnet, about a millionth as strong, but it spans the entire galaxy, guiding the movement of charged particles and shaping the paths of cosmic rays. This magnetic field is tangled and complex, twisted by the rotation of the galaxy and by the winds from stars. We're still learning how it works, still mapping its structure. It's yet another layer of mystery wrapped around our cosmic home. Cosmic rays and radiation. Space isn't empty. It's filled with cosmic rays, high-energy particles, zipping through the galaxy at nearly the speed of light. Most of them are protons, the nuclei of hydrogen atoms accelerated by supernova explosions or other violent events. These cosmic rays rain down on Earth constantly. But our atmosphere protects us, absorbing them before they reach the ground. Every now and then, one hits your body right now. In fact, about one cosmic ray is passing through you every second. You can't feel it. It's harmless, just a tiny reminder that you're part of this vast, energetic cosmos. The galactic ecosystem. Think of the Milky Way as an ecosystem. Stars are born in nebulae. They live and create energy and light. They produce planets and sometimes life. They die and return their material to space. And the cycle begins again. Gas flows inward toward the center, where it's compressed and forms new stars. Supernova explosions blow gas outward, enriching the galaxy with heavy elements. Gravity pulls things together, energy pushes them apart. It's a balance, a dance that's been going on for billions of years. And it's still happening right now. Even as you rest here, stars are being born. Stars are dying. Planets are forming. Gas is swirling. The galaxy breathes. Voyager's journey. In 1977, humanity launched 2 spacecraft, Voyager 1 and Voyager 2, to explore the outer planets. After completing their missions, they kept going, out toward interstellar space. Voyager 1 is now more than 15 billion miles from Earth, moving at about 38,000 miles per hour. It's the farthest human-made object from home. In about 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445. But Voyager's journey through the Milky Way has only just begun. It will continue drifting for billions of years, long after Earth is gone, long after the Sun has died. On board each Voyager is a golden record, a collection of sounds and images from Earth. Music, greetings in 55 languages, pictures of humans and nature. It's a message in a bottle, thrown into the cosmic ocean, just in case someone finds it someday. Hello from the children of planet Earth, it says. And then, silence. The great silence. Which brings us to a question that haunts every astronomer who looks up at the night sky, with hundreds of billions of stars in the Milky Way, with billions of planets, with billions of years for life to evolve. Where is everyone? This is called the Fermi paradox. If intelligent life is common in the galaxy, we should see evidence of it, radio signals, megastructures, something. But we've looked, and we've found nothing. The galaxy is silent. Maybe we're the first. Maybe intelligence is rarer than we think. Maybe civilizations destroy themselves before they can reach the stars. Maybe they're out there, but quiet, watching and listening. Or maybe the distances are just too vast. Space is so big, time is so long, and civilizations are so brief. Maybe we're all calling out into the darkness. just missing each other by millions of years or thousands of light years. It's lonely, in a way, but it's also strangely peaceful. The galaxy is ancient and vast, and we're here, small and brief, looking up in wonder. And that wonder, that's enough. The spiral arms in detail. Let's return to those spiral arms for a moment. The Perseus arm, the Norma arm, the Scutum Centaurus arm, the Sagittarius arm, and our own Orion spur. These arms are where most star formation happens. Gas and dust pile up in the arms due to density waves, like traffic slowing on a highway. This compression triggers the collapse of clouds, and new stars ignite. The arms aren't permanent structures. They're patterns that move through the galaxy like ripples on water. Stars drift in and out of them over millions of years. Right now, our solar system is between the Perseus and Sagittarius arms, in that little spur. In 10 or 20 million years, we'll have drifted somewhere else. From Earth, we can see portions of these arms when we look at the night sky. That glowing band of the Milky Way is thickest when we look toward the galactic center, toward Sagittarius. It's fainter when we look outward, toward Perseus. We're seeing our own galaxy from the inside, edge on, and it's magnificent. The Milky Way's age and evolution. Our galaxy is old, 13.6 billion years old. It formed from smaller proto-galaxies that merged together in the early universe, pulled together by gravity. The oldest stars in the Milky Way are about 13.2 billion years old, born when the universe was only 400 million years old. These ancient stars are metal poor, made almost entirely of hydrogen and helium, because the heavier elements hadn't been created yet. Over time, as generations of stars lived and died, the galaxy became enriched with heavier elements. Carbon, nitrogen, oxygen, iron, all the ingredients needed for planets and life. Our Sun, born 4.6 billion years ago, is a third-generation star rich in these elements. That's why we have a rocky planet to live on. The Milky Way will continue evolving. In a few billion years, it will merge with Andromeda. The resulting galaxy will be larger, brighter, more elliptical. The night sky will change. New stars will form from the collision of gas clouds. It will be chaos, and it will be beautiful. But long, long after that, perhaps 100 trillion years from now, when the last stars have flickered out and the universe is dark and cold, the Milky Way, or whatever it's become, will still be there. Silent, invisible, but there. A monument to 100 billion years of light and life. The view from Earth. Have you ever been somewhere truly dark? Far from cities, away from streetlights, where the only light comes from the sky. If you have, you've seen the Milky Way as a glowing river across the heavens. Thousands of stars blending together into a soft, luminous band. It's one of the most beautiful sights in nature. Ancient peoples saw it every night. They told stories about it, navigated by it, wondered at it. But today, with light pollution, most people never see it. 2/3 of people in the United States can't see the Milky Way from their homes. It's still there, of course. Every night, whether we see it or not, our galaxy stretches across the sky, beautiful and indifferent. Maybe someday you'll find yourself under a dark sky, and you'll look up, and you'll see it, and you'll remember that you're looking through the disk of a galaxy, looking at your own cosmic home from the inside. And maybe you'll feel, just for a moment, how small you are, and how vast the universe is, and how precious and unlikely it is that you're here at all, alive and conscious, able to look up and wonder. Satellite galaxies. The Milky Way has companion smaller galaxies that orbit it like moons orbiting a planet. The largest and most famous are the Large Magellanic Cloud and the Small Magellanic Cloud, visible from the southern hemisphere as fuzzy patches of light. The Large Magellanic Cloud contains about 30 billion stars small compared to our 100 to 400 billion. But still a respectable galaxy in its own right. It's about 160,000 light-years away, close enough that the Milky Way's gravity is slowly pulling it in. In a few billion years, it might merge with us, adding its stars to ours. There's also the Sagittarius Dwarf Elliptical Galaxy, discovered only in 1994 because it's on the far side of the Milky Way, hidden behind the galactic center. It's being torn apart by our galaxy's gravity, stretched into long streams of stars. It's a reminder that galaxies can be cannibals, consuming smaller neighbors over billions of years. At least 59 smaller satellite galaxies orbit the Milky Way. Most are dwarf galaxies, dim and difficult to see, but each one is a world unto itself, with its own stars and history. The Milky Way's bar. The Milky Way isn't just a spiral galaxy, it's a barred spiral. That means the center has an elongated bar-shaped structure made of stars and gas, stretching about 27,000 light-years from end to end. This bar rotates, and it affects how gas and stars move in the galaxy. It funnels gas toward the center, feeding star formation and possibly the supermassive black hole. It's a dynamic structure, always moving, always shaping the galaxy's evolution. We didn't know the Milky Way had a bar until relatively recently. It's hard to see your own galaxy's structure when you're inside it, like trying to describe a forest when you're standing among the trees. But infrared observations in the 1,990 seconds confirmed it. The Milky Way has a bar. We live in a barred spiral. Metals in astronomy. Here's a fun quirk of astronomy. To astronomers, anything heavier than hydrogen and helium is a metal. So oxygen is a metal, carbon is a metal. It's confusing if you're a chemist. But it makes sense when you remember that the universe started with only hydrogen and helium. The Milky Way's metallicity, its abundance of these heavier elements, has increased over time. The oldest stars are metal poor. Younger stars, like the Sun, are metal rich. This metallicity is crucial for planet formation and life. You need those heavier elements to build rocky worlds and complex chemistry. Our Sun's metallicity is actually slightly higher than average for stars in our part of the galaxy. That's lucky for us. More metals mean more material to build planets and life. Globular clusters as time capsules. Those globular clusters orbiting the galactic halo? They're like time capsules. Because they're so old and so isolated, they've remained largely unchanged for billions of years. Studying them gives us a window into the early universe. The stars in globular clusters are ancient, metal poor, and their chemistry tells us what the galaxy was like when it was young. There's something humbling about looking at a globular cluster through a telescope. Those stars have been shining for longer than Earth has existed. They'll continue shining long after we're gone. They're witnesses to deep time, to the slow turning of the cosmic wheel. The Milky Way's future. In about 5 billion years, our sun will begin to die. It will swell into a red giant, consuming Mercury and Venus, possibly Earth. Then it will shed its outer layers, creating a planetary nebula, and collapse into a white dwarf. But the Milky Way will barely notice. One star among hundreds of billions. The galaxy will go on. In 4.5 billion years, Andromeda will arrive. The collision merger really will take a few billion years to complete. Stars will be rearranged. The spiral arms will disappear, replaced by the smooth, featureless glow of an elliptical galaxy. Star formation will spike during the merger as gas clouds collide, then gradually decline as the gas is used up or expelled. Eventually, the merged galaxy will settle into a new equilibrium. Milkomeda, a cosmic giant. But even then, the story isn't over. Over trillions of years, stars will burn out. New stars will still form, but more slowly. The universe will continue expanding, carrying other galaxies away, until Milkomeda is alone in an empty cosmos. And finally, in the deep, deep future, 100 trillion years from now, maybe more, the last star will flicker out. The galaxy will go dark. Only black holes and dead stellar remnants will remain, slowly orbiting in the darkness, waiting for eternity. The Milky Way and other galaxies. Our galaxy is one of hundreds of billions in the observable universe. Some are larger, some smaller. Some are spirals like us, some are ellipticals, some are irregular blobs of stars. The largest galaxy we know of is IC 1101, an elliptical galaxy 1.04 billion light-years away. It contains about 100 trillion stars, 250 times more than the Milky Way. It's a monster, formed from countless mergers over billions of years. But size isn't everything. The Milky Way is beautiful in its structure, its spiral arms, its active star formation, and, most importantly, it's ours. Its home. The observable limits. From Earth, we can see about 6,000 stars with the naked eye under perfect conditions. That sounds like a lot, but it's an incredibly tiny fraction of the galaxy's stars, about 0.000001% of them. Most of those visible stars are relatively close, within a few hundred light-years. The farthest star you can see with the naked eye is V762 Cassiopeiae, about 16,000 light-years away. It's visible only because it's incredibly bright, a blue supergiant, about 100,000 times more luminous than the Sunday. So when you look at the night sky, you're seeing a tiny, local neighborhood of the Milky Way. The vast majority of the galaxy is invisible to your eyes, hidden by distance and dust. But knowing it's there, that helps, doesn't it? Knowing that beyond what you can see, there are billions more stars, each one a sun, each one possibly surrounded by worlds. The darkness isn't empty, it's full. The chemistry of life. Everything you are came from the Milky Way. The carbon in your muscles, the calcium in your bones, the iron in your blood. All of it was forged in stars that died billions of years ago. When massive stars explode as supernovae, they create and scatter the heavy elements needed for life. These elements drift through space, eventually collecting into new clouds, new stars, new planets. And occasionally, on at least one planet we know of, that matter becomes alive. It becomes conscious. It looks up at the stars and wonders where it came from. And the answer is right there, written across the night sky. You came from there, from the Milky Way, from exploded stars and ancient nebulae. You are the galaxy contemplating itself. There's something deeply comforting about that, isn't there? You're not separate from the universe. You're not an observer looking at something distant and alien. You're part of it, made of it. The same atoms that form stars form you. The same forces that guide galaxies guide the beating of your heart. You belong here. You always have. The interstellar medium. Between the stars lies what astronomers call the interstellar medium, gas and dust spread thinly through space. It sounds empty, but it's not. It's just sparse. On average, there's about 1 atom per cubic centimeter. For comparison, the air you're breathing has about 10-19 atoms per cubic centimeter. But space is so vast that even this sparse material adds up. The interstellar medium makes up about 10-15% of the galaxy's visible mass. It's the raw material for new stars, the leftover debris from old ones, and it plays a crucial role in the galaxy's ecosystem. This medium isn't uniform. It has structure-dense molecular clouds where stars are born, warm neutral regions, hot ionized bubbles created by supernova explosions. It's a tapestry of temperatures and densities, constantly changing, constantly recycling. And it's beautiful. When light from stars passes through dust, it scatters, creating colorful nebulae. The dust itself, tiny grains of carbon, silicon, and metals glows with infrared light. Even the empty space between stars is full of light, if you know how to look. Pulsars, cosmic lighthouses. When certain massive stars explode, their cores collapse into neutron stars objects, so dense that a teaspoon of their material would weigh as much as a mountain. Some of these neutron stars spin incredibly fast, hundreds of times per second, and emit beams of radiation from their magnetic poles. If those beams happen to sweep past Earth as the star spins, we detect regular pulses of radio waves. These objects are called pulsars, and they're some of the most precise timekeepers in the universe. The first pulsar was discovered in 1967 by Jocelyn Bell Burnell. The pulses were so regular that, for a moment, scientists wondered if they'd found an alien signal. They jokingly called it LGM-1, Little Green Men. But it turned out to be something even stranger than aliens. A star so dense and so fast that it defied imagination. There are thousands of known pulsars in the Milky Way. Each one is a remnant, a ghost of a massive star that once burned bright. And they spin there in the darkness, sending out their regular pulses like lighthouses in the cosmic ocean. The speed of the Milky Way. We mentioned earlier that our solar system orbits the galactic center at about 515,000 miles per hour. But that's just the beginning of our motion. The Milky Way itself is moving through space. It's falling toward the Virgo cluster, a massive collection of galaxies, at about 1.3 million miles per hour. Meanwhile, our entire local group of galaxies is being pulled toward something called the Great Attractor, a massive concentration of mass about 150 million light-years away. And beyond that, the universe itself is expanding, carrying distant galaxies away from us faster and faster. So you're not just sitting still. Right now, as you lie there, you're moving in at least 4 different ways. Earth is spinning. Earth is orbiting the Sun. The Sun is orbiting the galactic center, and the Milky Way is falling through the universe. You're on the most spectacular ride in existence, and you can't even feel it. The zone of avoidance. There's a region of the sky where we can't see distant galaxies. It's not because there aren't any galaxies there. It's because the disk of the Milky Way is in the way. The plane of the galactic disk is thick with dust and gas, and it blocks our view of anything behind it. This region is called the zone of avoidance, and it covers about 10–20% of the sky. Astronomers are finding ways around this, using infrared and radio telescopes that can see through the dust. We're slowly mapping what's hidden in the zone of avoidance, finding galaxies and galaxy clusters we never knew existed. It's a reminder of our limitations. We can only see what we can see. There's always more, just beyond our reach, waiting to be discovered. Stellar nurseries. Let's return once more to where stars are born, to the molecular clouds, cold and dark, where gravity is slowly winning its patient battle against pressure. These clouds are vast, hundreds of light-years across, and they're opaque. Visible light can't penetrate them. From the outside, they look like dark patches, holes in the starfield. But inside, something magical is happening. As the cloud collapses under its own gravity, it fragments into smaller clumps. Each clump continues collapsing, getting denser, getting hotter. Eventually, the pressure and temperature at the core become high enough for nuclear fusion to ignite. Hydrogen atoms slam together, forming helium, releasing tremendous energy. A star is born. The process takes millions of years. By human standards, it's impossibly slow. And when it's done, the darkness lights up with new stars, hot and bright, blowing away the remnants of their birth cloud with powerful stellar winds. And around some of those stars, the leftover material, dust and gas too far from the star to be blown away, begins to clump together. Over millions of years, these clumps become planets. Rocky worlds close to the star, gas giants farther out. And maybe, on some of those rocky worlds, given enough time and luck and life, the Milky Way's halo, that spherical halo surrounding the galaxy, the one containing globular clusters and old stars, also contains something else. Dark matter. The halo extends far beyond the visible disk, perhaps 500,000 light-years or more. It's mostly empty space, but threaded through with dark matter, that mysterious, invisible substance that makes up most of the galaxy's mass. There might also be ancient, faint stars drifting through the halo. Streams of stars from dwarf galaxies the Milky Way has consumed over billions of years. If you could see the whole galaxy from outside, you'd see these streams, like faint ribbons, evidence of cosmic violence from eons past. The halo is the galaxy's memory. It holds the remnants of mergers, the oldest stars, the invisible scaffolding of dark matter. It's the foundation everything else is built on. Hypervelocity stars. Most stars in the galaxy orbit the center in an orderly fashion, moving at predictable speeds. But occasionally, something dramatic happens. Sometimes a binary star system gets too close to the supermassive black hole at the galactic center. The intense gravity can tear the system apart, flinging one star out of the galaxy at speeds exceeding 1,000 kilometers per second, over 2 million miles per hour. These are called hypervelocity stars, and they're escaping the Milky Way entirely. They'll wander through intergalactic space for billions of years, forever exiled from their home galaxy. We've found a few dozen of these runaway stars so far. Each one tells a story of a close encounter with something massive and violent. Each one is on a one-way journey into the cosmic void. The bulge population, that central bulge of the galaxy, about 10,000 light-years across, is densely packed with old red stars. It's a chaotic place. Stars orbit in random directions, unlike the orderly rotation of the disk. This bulge formed early in the galaxy's history, when gas collapsed rapidly toward the center, triggering intense star formation. Those stars are now ancient, having exhausted most of their fuel, glowing with a warm, reddish light. The density of stars in the bulge is hundreds or even thousands of times higher than in our neighborhood. If Earth were located there, our night sky would be filled with brilliant stars, so many that they'd cast shadows even at midnight. But the bulge is also a dangerous place. More supernovae, more radiation, more gravitational chaos. Life would have a harder time surviving there. Maybe that's why we're out here in the suburbs, where it's quieter, safer, calmer. The Milky Way's magnetic personality, that galactic magnetic field we mentioned earlier, it's generated by the movement of ionized gas in the galaxy, charged particles flowing through space, creating electric currents, creating magnetic fields. This field shapes the spiral arms, guides cosmic rays, and influences star formation. It's weak, but it's everywhere, threading through the entire galaxy like an invisible nervous system. We're still learning how it works. Mapping it requires careful observation of how dust grains align with the field, how light polarizes as it passes through magnetized regions. It's painstaking work, but slowly we're building a picture of the galaxy's magnetic anatomy. The search for exoplanets. For most of human history, we could only wonder if other stars had planets. Now we know they do. Almost all of them. The first exoplanet orbiting a sun-like star was discovered in 1995. Now we've confirmed over 5,000, with thousands more candidates waiting to be verified. Some are hot Jupiters, massive gas giants orbiting close to their stars, baked to thousands of degrees. Some are super-Earths, rocky worlds larger than Earth but smaller than Neptune. Some are in the habitable zone, where liquid water could exist. One day, maybe soon, we'll find a planet that's truly Earth-like. Similar size, similar temperature, signs of water, and an atmosphere. And then we'll ask the next question. We don't know yet. But the Milky Way is vast, and the odds are good. Somewhere out there, under a different sun, life might be looking up at their night sky, wondering the same thing we are. Are we alone? Galactic archaeology. By studying the chemistry and motion of stars, astronomers can reconstruct the Milky Way's history. It's like archaeology, but with stars instead of pottery. Different populations of stars have different chemical signatures, depending on when and where they formed. Old stars are metal-poor, young stars are metal-rich. Stars in the disk move in orderly orbits. Stars in the halo move chaotically. By mapping these patterns, we can see echoes of ancient mergers, smaller galaxies that collided with the Milky Way billions of years ago, their stars now mixed with ours. One recent discovery was the Gaia-Enceladus merger about 10 billion years ago. A dwarf galaxy containing about 600 million stars collided with the Milky Way. The collision disrupted our galaxy, thickening the disk, adding stars to the halo. We can still see the remnants of that galaxy today, a ghostly signature in the motion and chemistry of certain stars. The Milky Way isn't static. It's a living, evolving entity, shaped by billions of years of collisions, mergers, and star formation, and we're reading its history, one star at a time. The cosmic calendar. Let's put the Milky Way's history in perspective. If we compressed all 13.6 billion years of its existence into a single calendar year, with the Big Bang on January 1st and today on December 31st at midnight, the Milky Way would form in mid-January. The first stars would ignite shortly after. Our solar system wouldn't form until September 1st. Life on Earth would begin in mid-September. Complex multicellular life wouldn't appear until mid-December. Dinosaurs would emerge on December 26th and go extinct on December 30th. All of human history, every civilization, every empire, every person who's ever lived would occur in the last 10 seconds before midnight on December 31st. You, lying here, listening to this, you exist in the last fraction of a second of this cosmic year. A blink, a breath, and yet here you are, aware of all of it, able to comprehend billions of years of history. That's remarkable. You're remarkable. The quiet comfort of vastness. There's something deeply peaceful about the scale of the galaxy. Small, brief. The Milky Way has been here for 13.6 billion years. It will be here for billions more. Stars have been born and died over and over in an endless cycle. The galaxy doesn't hurry. It doesn't worry. It just exists. Patient, eternal, and you're part of that. Not separate from it, but woven into it, made of star stuff. Temporary? Yes. Brief? Yes. But real, conscious, capable of wonder. So let that sink in. Let the vastness of the galaxy wrap around you like a blanket. Let it remind you that you're small enough to rest, but significant enough to matter. 100 facts. We've traveled far tonight, through spiral arms and globular clusters, past black holes and nebulae. We've met stars being born and stars dying. We've counted billions of stars and billions of years. The Milky Way is ancient and vast and beautiful. It's home to everything we've ever known, everyone we've ever loved, every story that's ever been told, and it's still mostly mystery. Dark matter we can't see, planets we haven't discovered, questions we haven't thought to ask, but that's okay. Mystery is part of what makes it beautiful. 100 facts about the Milky Way. But really, we've only scratched the surface. There are billions more facts waiting to be discovered, billions more stories waiting to be told, and maybe someday, someone will discover a new fact, a new star, a new world. Maybe that someone will be inspired by a night like this, lying in the dark, listening to stories about the galaxy. Maybe that someone is you, closing gentle wind down. But that's a thought for another day. Right now, there's nothing you need to do, nowhere you need to go. The galaxy is out there, spinning slowly, and you're here, safe and comfortable, drifting towards sleep. Let your breathing slow. Let your thoughts quiet. Let the darkness behind your eyelids become the darkness of space, peaceful, infinite, welcoming. The Milky Way will still be there in the morning. The stars will still be shining. And when you wake, you'll carry these stories with you, like seeds planted in the quiet soil of your mind. Thank you for exploring the galaxy with me tonight. If you enjoyed this journey, consider subscribing to the channel. There are so many more wonders to discover together, but don't worry about that now. For now, just rest. Let the galaxy hold you, the way it's held everything for billions of years. Let the stars watch over you, the way they've watched over Earth since the beginning. And let sleep come, gently, softly, like starlight falling on a quiet world. Good night, traveler. Sleep well. The universe will still be here when you wake.